Good morning and welcome back to Chapter 1. Today we're going to be looking at Section 4, which is on literal equations and formulas. That's kind of redundant because literal equations are formulas and vice versa, at least for all intents and purposes. So our learning targets today. We're going to be rearranging formulas to isolate a variable. You'll be able to use formulas and equations to solve problems. So, we have literal equations. I know some people think it's literally an equation. That's not the word of it, or that's not the meaning of the word. Literal means letters. It's just an equation involving letters. Some examples of a literal equation would be things like the area of a rectangle. A equals L times W. Area equals length times width. The area of a perimeter of a rectangle. P equals 2L plus 2W. And this one, which is the formula to change Fahrenheit temperatures into Celsius temperatures. C, the degrees Celsius, equals 5/9 times F, the degrees Fahrenheit, minus 32. So these are all different literal equations. What would we be doing with these? Well, we'll be doing a couple things with them. The first thing we'll be doing is we'll be solving for a specific variable. For instance, in the first one, it may tell us to solve for the length. We're going to solve for the length. Well, we have the length times the width. How do we get rid of multiplication when we're dealing with numbers? We just divide. So we're going to do the same thing. We're just going to divide by W. And so that means that, well, what is A divided by W? It's simple. It's just A divided by W. You don't need to simplify anything. So A over W equals the length. And then it might have us use it. It could ask, what is the length when the area equals 30 and the width equals 5? And it might give us units like centimeters squared and centimeters, or whatever it is, but it's the numbers here. And you just plug it in. 30 over 5 equals L. Well, what is 30 divided by 5? 6 equals L. So the length would be 6. And if it's in centimeters, it would be 6 centimeters. If it's inches, it would be 6 inches. And so that's how we solve for a variable. And then the application. Let's do another couple examples here. Let's look at the perimeter example. P equals 2L plus 2W. In this case, let's solve for W. So we need to get W by itself. Well, we have the 2L to get rid of, and we have the 2 to get rid of. We get rid of the addition first, just like solving equations. So we're going to subtract 2L from both sides of the equal sign, just like before. All right, well, what is P minus 2L? It's just P minus 2L. Remember, there's really no simplifying involved here. You're just moving stuff over. Equals, we have a 2W left over. So then we need to divide by 2. So I'm going to switch the equal sign. Instead of blah, blah, blah equals W, I'm going to say W equals P minus 2L over 2. You could go 1/2 P minus L. Like you could split it up into two fractions, but I would leave it like this. What you don't want to do is you don't want to cancel the 2's here, because that P doesn't have a 2. You can't cancel it. The top is not all multiplication. But W equals P minus 2L over 2. And then it'll say, all right, well, what's the width if the perimeter is 52 and the length is 10? What's the width going to be? All right, well, just plug stuff in. Width equals the perimeter is 52 minus 2 times the length, which is 10, over 2. We're going to simplify. We have 52 minus 2 times 10 is 20 over 2. 52 minus 20 is 32 over 2, and 32 divided by 2 is 16. So the length was 10 whatevers, and the width is now 16. Again, if you have units to begin with, you want to keep your units in there. So there's that. Let's do one more. This right now, we have the conversion from Fahrenheit to Celsius, which is great if you're like from Canada or Europe or pretty much anywhere else in the world, and you're here and you see that, oh, the temperature is 72 degrees Fahrenheit. Well, what is that in numbers that I'm thinking of? But maybe we need to use it to transfer back to Fahrenheit. So we would solve for F. Solve for Fahrenheit. First thing we'd want to do is get rid of that 5/9. To do that, to get rid of multiplication, we divide. Well, what does dividing by 5/9 look like? Dividing by 5/9 looks like multiplying by 9/5. Right? When we divide by a fraction, we multiply by the reciprocal. We flip and we multiply. So this is going to be 9/5 C equals F minus 32. Then we can add 32. So we get 9/5 C plus 32 equals F. And then we can say like, all right, so I was watching the Canadian News Channel, because we get that up here, and it said that the temperature was 20 degrees Celsius. And I want to know what that is in Fahrenheit. I want to know, like, is that a hot day? Is that a cold day? I don't know. So we're going to plug that in. So the Fahrenheit temperature will be 9/5 times the Celsius temperature plus 32. So 9/5 times 20, I would go 20 divided by 5 first to get 4, and then multiply by 9 to get 36. I like doing things the easy way though. Plus 32. 36 plus 32 equals 68 degrees Fahrenheit. So when it's 20 degrees Celsius, that makes it 68 degrees Fahrenheit. Is that a warm day or a cold day? Well, it depends on your opinion of that, and really whether or not it's sunny. So anyway, these are literal equations and formulas. We're using the exact same skills we've been using all chapter to solve for a variable, except now we just have other variables. We won't have to do a lot of simplifying in the fraction or in the solving stage. And then once we have it, we might be asked to apply it by plugging in values for certain variables and simplifying to find that last value. So this is what we have for section 4. I will see you in class. We'll talk about more then. But until then, keep working problems, keep asking questions, and as always, happy mathing.